Welcome to the final lesson of Unit 4, which is about parallel lines. Here are the two things you need to know about parallel lines. The first is that they are lines that will never intersect, so they'll never hit each other as long as you extend them. And the other thing to know about them as far as equations are concerned is that they will always have the same slope, but a different y-intercept. Alright, so we'll see problems like this which say, which lines below are parallel? Remember that idea we talked about that parallel lines have the same slope. So if we look at each of these three equations that all happen to be in slope-intercept form, we should be able to identify what their different slopes are. This equation has a slope of 3, this second equation has a slope of -2, and this third equation has a slope of -2. So B and C both have the same slope and different y-intercepts. If they had the same y-intercept, they'd be on top of each other. So same slope and different intercept means that these are parallel lines. So B and C are parallel. A has a different slope, so it's not parallel to the other two. Next, they ask us to do the same thing, but using a graph as well. Well, I can tell from the beginning of this problem that these two guys, because they're both in slope-intercept, they both have the same slope. So these are going to end up being parallel, but let's graph them both and see what that looks like. For f of x, our slope is -3, and our y-intercept is +2. So let's graph that guy. That slope of -3 means go down 3 and right 1, and we're starting at 2. So start at 2, go down 3 and right 1, and then keep going until you fill out the graph. There we go, I'm out of space, so I connect the dots, and there's my first line. And then this g function has a slope of -3/1 as well, and this one starts at -1. So I start at -1, and I go down 3 and right 1, and I'll do that till I run out of space. And you notice that these lines aren't getting any closer to each other because they're parallel. They'll never intersect. Now let's take a look at 5. This time I notice that the two slopes are not the same. They kind of look similar, 2 and -2, but they're not the same, so I bet these won't be parallel. Let's graph the f of x. It has a slope of 2/1 and a y-intercept of 3. So I start at 3 and go up 2/1 till I run out of space. Remember, I go down 2 and left 1 to go backwards. Connect the dots, and there's my f of x graph. And now g of x has a slope of -2/1, so down 2, right 1, and also a y-intercept of 3, so they have the same y-intercept. And now we'll go down 2 and right 1 until we run out of space. And we see that visually, these are not parallel. They intersect with each other. And obviously, as we said, they have different slopes, so they're not parallel. So let's write out a conclusion for each of these. Pretty easy here. We're just going to say, yes, parallel, because these lines in 4 are parallel. And then for 5, we're going to say not parallel, because they don't have the same slope and they intersect with each other. Now in 6, it's a little bit harder to see, because these equations are not in slope-intercept form. This first equation is in point-slope form. So we learned in the last lesson that we can identify a point here. Remember, we're supposed to see subtraction. So if we see addition, that means it's a negative. So our x-coordinate is -6. It might help you if I put that point slope above it so you can see what goes where. And the y-coordinate is a +2. And my slope is this 2/3, up 2, right 3. Now we can throw this on the graph, starting at -6, and going up 2 and right 3 until we run out of space. Now as far as standard form here goes, we could do this with intercepts, or we could do this by putting it in slope-intercept form. Since I'm comparing the slopes, I kind of want to put it in slope-intercept form so I can see if they have the same slope. So I'm going to add 4x to both sides, and I'm working to get y alone right now. And then I'm going to divide by 6 to get y equals 2/3 x plus 1. Now you might have forgotten to simplify this 4/6, but even if you used the 4/6 and went up 4/6, you'd actually end up noticing that these graphs are still the same, that these slopes are still the same. So my slope is 2/3, up 2, right 3, which happens to match the other slope, so I'm guessing these are parallel, and my y-intercept is 1. We didn't really know this guy's y-intercept yet. We know it if we look at the graph, but we'll be able to know for sure when we graph our function if they have the same y-intercept or not. So I start at 1, and I go up 2/3 until I run out of room. And the graph, as well as comparing the slopes, tell us that these lines are again parallel. Finally, in number 7, We are given these special cases. We don't have a y equals mx plus b or standard or point slope. So these must be vertical or horizontal lines. Remember, x equals lines are vertical and y equals lines are horizontal. And if you just look at the little sketch that I showed to say if they're vertical or horizontal, it's pretty clear that these are not going to be parallel, but let's graph them anyway. X equals -3 means start at -3 on the x-axis and graph a vertical line. And y equals 5 means start at 5 on the y-axis and draw a horizontal line. And it's pretty clear that these two intersect and are not parallel. And that's it. All right, this was one of the more straightforward lessons we've ever had. Parallel lines have the same slope and they never intersect. That's the big takeaway from this lesson. If you came away with anything else, write it down now. Otherwise, we'll see you next unit.